Hi everyone, welcome to assignment 67. We're just going to continue the work with log expressions that we were working on in the last video. And of course I want to consider changing logs to exponentials or exponentials to logs. So let's just start with some of that, like log x equals -8. Can you rewrite this as an exponential so that we can know what x is equal to in this situation? Okay, so I'm wondering, did you remember that that was log base 10? Did you remember you could scorpion tail this? Base, power, answer. Okay, so 10 to the -8th equals x. You could also think about this graphically. This is saying, when does the log graph, 10, 1, 1, 10th, -1. When does this log graph intersect y equals -8? And we see is going to be very close to 0. Very close. 4, 5, 6, 7, 8. That's the x value at that point. We're very close to 0. Okay. You could also solve this equation. Log of x equals -8. I can solve this equation because I know that this is log base 10, and so I can exponentiate both sides of the equation with 10. 10 to the power of log base 10 cancels, and I'm left with x equals, ta-da, 10 to the -8th. No scorpion tail needed when you exponentiate. Okay, so will you do this one then? ln of x equals 1/2. Please solve that equation for x. So, did you scorpion tail it? Did you exponentiate? Did you remember that ln is the same as log base e? So when I see this, if I exponentiate, e is my base, power, answer. Like that. But I could also, exponentiate with e. E to the power of log base e, those cancel, leaving me x equals e to the 1/2. It's not e times 1/2. This is the base, this is the power. It's e raised to the 1/2, which I guess is the same as square root of e. Okay. Next, how about this? Log base 5 of 1 equals. Now, we talked about these in the last video, and I expressed that I would like you to be very, very comfortable with these. If you're not, I'm sad face. This is going to be 0. How do I know that? Well, let's take a look at the graph of log base 5 of x. Okay, so this is 1/5, -1. This is 1, 0. And this is 5, 1. Don't forget x equals 0 over here. Now this says log base 5 when x equals 1. Here's when x equals 1. And what's that equal to? Ta-da! I can know this graphically. I can certainly scorpion tail it. 5 raised to what power will be 1? Oh, the power has to be 0. Okay, so next, log base 3 of 3. 5, 4, 3, 2, 1. Well, I hope you said that that was equal to 1. Whether you thought about it on the graph that when x equals 3, y equals 1, or if you said, hey, I don't know what this is, But I could write 3 to the question mark equals 3, scorpion tail, and then say, okay, well, because the bases are the same and the terms are equal, the powers have to be equal to each other. So question mark is 1. You could also exponentiate with 3. 3 equals 3 to the question mark. And we're in that same place again. Okay. All right. How about this one? Log base 7 of 7 squared. What's that going to be equal to? 5, 4, 3, 2, 1. Well, I hope you came up with 2. And I'm kind of interested, if you did come up with 2, which method did you use? Did you say log base 7 of 7 raised to the power of? These are inverse operations and cancel, leaving me the 2. Or did you say, I don't know what that's equal to, and then do a scorpion tail? 7 to the question mark equals 7 squared. Since the bases are the same and the terms are equal, the powers also have to be the same. And so this expression equals 2. You could even say that you'll exponentiate. Cancel. I get 7 squared equals 7 to the question mark. And I get to that same place. Okay? All right. How about this one? Log base 7 of 1. 5, 4, 3, 2, 1. I hope you came up with 0 for this. You know, I just keep thinking about when x equals 1, what's the y value there? That's what this is saying. On this graph of log, when the x value is 1, what's the y value? Well, the y value is 0. You could, of course, scorpion tail this. 7 to the question mark equals 1. I've seen a lot of students get stuck here, though. Like they can't think of a power to use, even though they know, hey, if I raise something to the 0 power, that's going to be 1. Okay, so what about this one? Log base 5 of 0. What's that equal to? What can you say there? Oh, yeah, that's interesting. I mean, if I scorpion tail it, I have 5 to the 0. I'm sorry, 5 to the question mark equals 0. But, yeah. I know. Let's take a look at the graph and see what's happening at x equals 0. So here's a graph of log base 5, 5, 1, 1, 0, 1 fifth, negative 1. Don't forget the vertical asymptote here. Oh, x equals 0. What happens at x equals 0 on the log graph? Here's the log graph. What's happening at x equals 0? Dude, that's undefined. There's a big old vertical asymptote there. That's why we couldn't solve this. This is like saying, when does this exponential graph, which passes through negative 1, 1 fifth, 0, 1, 1, 5, with a horizontal asymptote at y equals 0, when does this exponential graph intersect y equals 0? Well, the answer is never. This never crosses that horizontal asymptote. This isn't a rational function. Exponential functions never cross. Yeah, so that's undefined. Whether I view it as a log or as an exponential, I know that this is not going to happen. Can't, no, doesn't work. Okay, so how about this one, by the way? Log base 7 of negative 1. What do we know about that? Yeah, I know. I just want to go back to the graph and say, all right, 7, 1, 1, 0, 1 seventh, negative 1, vertical asymptote here at x equals 0, And what they're saying is, on this graph, when the input is -1, what's the y value? Well, here's -1. There's nothing here. We say that's undefined. And so it might be useful to write down, I can't take the log of 0 or a negative. If someone shows you log of -2, you say, no way, that doesn't exist. If someone shows you ln of 0, you say, no, there's a vertical asymptote at 0. That doesn't exist. Okay? Okay. All right, how about this one? Log base 5 of 125. Whichever method you want. 5, 4, 3, 2, 1. Well, I like scorpion tail here. 5 to the question mark equals 125. Because I remember when we were doing algebra basics and working with exponential expressions there, we had problems like this, and we said we should rewrite them so they have the same base. This is 5 to the third. Oh, look, the bases are the same and the terms are equal, so what must be true about the powers? The powers have to be equal, so 3 equals question mark. And here's my question mark now, and that has to equal 3. Okay? Okay. How about this one? Log base 4 of 1 over 64. What's that equal to? 5, 4, 3, 2, 1. Did you get -3? Question mark. So how'd you do it? Scorpion tail gives me 4 to the question mark equals 1 over 64. I know that 64 is 4 to the third. In fact, if I moved this up, so it now said 4 to the -3, I could say that the bases were the same. These things are equal, and therefore the powers should be the same. So question mark should be -3. This question mark is -3. Okay? Okay. Next. How about this one? 3 raised to the log base 3 of 81. Now there are a couple ways we can do this problem, but I think the easiest one is to say 3 to the power of log base 3. These are inverses and cancel each other out. And so I'm left with 81. We could look at this way. We could think about this as log base 3 of 3 to the 4th. And then I could say, oh, look, log base 3, 3 to the power of, those are inverses. They undo each other. And I get the same 81. Okay? Okay. I think that's all of those that I want to look at. How about we do some basic solving? Log base 4 of x equals log base 4 of 8 minus x. How can we solve that equation? That's why. Okay. So there are a couple ways we can solve this equation. The book recommends that since these are both logs with the same base, that their argument, the stuff in the parentheses, should be equal. I'm not really fond of that. I mean, it's true. I can certainly solve this equation this way. But, yeah, and oh, by the way, remember that log graphs have this big old vertical asymptote and don't exist generally over here, log equations are always must checks. Because remember, I can't take the log of a negative number or 0. But if I plug this 4 in here, I have log base 4 of 4. What was log base 4 of 4 equal to? 1. And if I put this 4 in here, 8 minus 4 is 4. And again, I have log base 4 of 4. So 1 equals 1, or log base 4 equals log base 4. Either way. Yeah, either way I feel comfortable with those. Yeah, I don't want to do that one. Okay. Oh, and by the way, that wasn't the method I would do. I would exponentiate both sides. Yeah, these will always be the same for us, but there will be situations that we see 2 videos from now where we really just can't say, oh, look, the bases are the same, so the arguments should be equal. If we exponentiate 4 to the power of log base 4, they do cancel. 4 to the power of log base 4, they cancel. And so I can get to that same place without using that property that says if the bases are the same and these logs are supposed to be equal, then I know that the terms, the arguments must be equal. Okay. I don't want to do that. Well, maybe I do. You know, there's some questions that I see here that ask about domain. F of x equals log x plus 2. And maybe next we'll do f of x equals log of x plus 2. Okay, can you tell me the domain in each case? I know, it may help to think about these graphically. It also may help to remember what's the log base in each of these. 10. Good. So if I think about this graphically, I've got my reference points, 1 over 10, negative 1, 1, 0, 10, 1, and x equals 0, the vertical asymptote. Well, I don't see any x transformations here, but I see a y transformation. Everyone moved up 2. But that didn't change where this was. And there's no reflection going on here. This graph was just shifted up. And because this graph was shifted up, I've got here 1/10, 1, 1, 2, and 10, 3. My graph didn't shift left or right. The vertical asymptote is still in the same place. So my domain, 0 to infinity. And why is it that I'm using a parenthesis here and not a bracket? Well, if I plug a 0 in here, what's the log of 0? Oh, right, I can't take the log of 0 or the log of a negative. So 0 can't be included. That's why I've got a parenthesis there. If someone asked you for the range for these log functions is definitely negative infinity to infinity. They may have a restricted domain, but they cover all the y values. And I asked you to consider this one. Hey, this shifts my log graph left 2, including the vertical asymptote. This is an x transformation. I'd be subtracting 2 from all the x's, including that one. So now my graph isn't going to start at 0. It's going to start at negative 2. So I'm subtracting 2, I'm subtracting 2 here, like that. So there's negative 1, 0, and here's 8, 1. Okay? So my domain then, well, graph starts over here at negative 2 and goes forever that way. And the range is still negative infinity to infinity. Okie doke. Why don't you try this one? What's the domain of this one? F of x equals log base 4 of negative x. Please find the domain for that. Five, four, three, two, one. Okay, so how'd you do it? What did you think about it? Did you write down the reference points and carry out the transformation? Did you think just about, oh, that's a reflection across the y-axis? My vertical asymptote is still at x equals 0, but instead of this shape, I divide all those x's by negative 1. I get this shape. Negative 1, 0. Negative, oops, negative 4, 1. And down here, negative 1/4, negative 1. So what's my domain? Well, my domain, because this is going to go forever that way, my domain is going to be negative infinity to 0. My range is still negative infinity to infinity. The range is all the possible y values. I only have a restriction on x's. They can't go past here. Okay. All right. So how about this? Tell me what ln of e is. That took you too long. I need you to say 1. I need you to say instantly, ln of e is 1. This is going to come up so often. So often in this class, so often in calc, I need to know the ln of e is 1. What about the ln of 1? What do you mean you don't know? This is the same as log base e of 1. What was log base b of 1 equal to? Oh, b to the question mark equals 1. What does question mark have to be? Question mark is 0. This is equal to 0. Think about the graph. Here's x equals 1. What's the y value there? Oh, yeah. So, just like the ln over here at e is equal to 1, the ln of 1 is going to be 0. If I asked you, what's the ln of 1 over e? Well, that would be negative 1. And we're going to have a couple of ways to understand that as we move forward. Okay, how about this one? The ln of e squared. Is that equal? I know the ln of e is 1. Is this just 1 squared or 1? No. So what is it? How can I solve this? Well, let's exponentiate. E to the power of log base e, cancel. And I'm left over here with, whoa, Kukla. Sorry, too cavalier. ln of e squared. This is the same as log base e of e squared equals, I don't know what. Now what I'm saying here is, hey, I don't even have to exponentiate. I already have log base e of e to the power of, these are inverses, and undo each other. Just left with that 2. This is going to be 2. If I do think about exponentiating here, I'm going to cancel these out. And so I'll have e squared equals e to the question mark. So 2 equals question mark, which means this original expression, the ln of e squared, that was what my question mark was, and that's equal to 2. Okay. How about ln of e to the negative 1? What can we do there? How can we simplify this expression? What does this equal? Well, again, ln is log base e of e raised to the power of. Those are inverses and cancel each other out, and I'm left with negative 1. Okay? Okay. And e to the 2 plus ln of 3. Say what? Well, do you remember, not all the way back to pre-algebra or even algebra 1, just back to algebra basics unit, when we had x to the m times x to the n? What was that equal to? What could we do here when the bases are the same and I'm multiplying? That's right. I can add those exponents. So, if the bases are the same and I'm multiplying, I can add those exponents and rewrite the expression this way. Wah! I see some exponents being added. That means I could go in the other direction and write this as e squared times e to the ln of 3. Now, e to the log base e of 3, those cancel, and that just becomes 3. E squared is just some number, and so my answer is 3e squared. Okie doke. Okie doke. How about this one? E to the ln of 8. What can we do there? Yes, that's it. Log base e to the power of, they cancel, I get 8. Okay. Just because we went through a lot of these today, I think that doesn't necessarily mean that you have mastery on them, like log base 8 of 1, 5, 4, 3, 2, 1. Like that fast. I'd actually like it faster. How about log base 3 of negative 2? 5, 4, 3, 2, 1. And that does not exist. I can't take the log of a negative number. Okay? 5, 4, 3, 2, 1. Log base e to the power of, they cancel each other out, I'm left with 2. Okay? Log base b of b is 1. Log base b of 1 is 0. These are probably the most common, so please make sure you know those and are comfortable with those. Okay? Well, I hope this was good practice for all of you. I look forward to seeing you in class. And next time, we'll dig into log properties. Log properties is what's coming up next.